All right, recording. All right, so today then, we're going to continue to look at the composition of an atom. Right, that's our basis for this unit. And after this unit, once we have understood the symbols and the atomic number and the mass number and where they're located and where the information comes from and how we're going to use that, once we have established that this unit, on the following units, we go back to just writing the symbols, knowing that where we can find the information. Okay, but for now, we want you to write it with all the information given. All right, so ions is another term that we'll look at, ions. And simply put, how would you define or describe an ion from the reading that you did and maybe back in 8th grade a few years ago? What is an ion?
The atom with a charge.
What's that?
An atom with a charge.
An atom with a charge. I like that. Okay. So I just put a charged atom. Okay, a charged atom. So the question would be, how can an atom become an ion? There's one of two ways an atom can become an ion. And this is from the reading in 4.3. If you read and took notes on that, it should be in there someplace. Again, the reason why you took notes this way is to see how you took notes, if it matches with what we cover in class. And if not, then it just gives you an indicator of how you need to take notes on your own. Okay? All right, so back to our question, how can an atom become an ion? How can an atom become charged? What can it do? So let's pick on a phosphorus ion, or a phosphorus atom. How can a phosphorus atom become an ion? Can it lose neutrons, gain neutrons? That doesn't make it. Can it lose or gain protons? No, because if it does, it becomes a different substance, different atom. So what's left? Electrons. So in order for an atom to become an ion, it either can gain or lose electrons. Okay, it can either gain or lose electrons. So we'll pick an easy one here. We'll look at phosphorus. 15 and 31. How many protons does phosphorus have? 15. How many neutrons? 16. And how many electrons? 15. So as a neutral atom, we have 15 protons, 15 electrons. So I can put my plus and minuses up here because they're charged. Okay. So 15 positive, 15 minus gives me a neutral atom. Okay, now, if phosphorus gains an electron through chemical reactions or whatever, what happens to my atom? It now becomes a 1 minus charge. Okay, so here we're gaining electrons. We could also maybe lose electrons, and we'll talk about if it does that a little bit later. Okay, so we're looking at losing and gaining electrons. If the atom gains electrons, it becomes a negative ion. Okay, just like we showed here. If it gains an electron, or multiple electrons, it becomes a negative ion because you're gaining a negative substance. Before we're neutral, gaining a negative substance, we become negative. Now, this negative ion has a special name for it. Okay? A negative ion is called an anion. Okay, a negative ion. They specifically call it an anion. A negative ion. Okay, if that helps you remember that, so A negative ion, again, if that helps you. Okay. So again, in this field of chemistry for this first year, first semester or trimester, a lot of new terms. It's like a new language. So make sure you're keeping track of vocab. Make sure you're keeping track of the terms that we're using. Okay. All right. So when we write our symbols, then how do we write an ion, an ionic symbol? Well, we're going to place a charge in the upper right side of the symbol. Okay, upper right side. And let's look at, when we write the symbol, or write the charge, the number comes first, followed by the sign. So we can either have a 1 minus or a 1 plus, that would be the charge. Do not write a minus 1 or a plus 1. This is what we call an oxidation number. Okay, you'll learn that more in Chem B. Okay, an oxidation number and the charge is not always the same. Okay, so please write the charge the way it's intended. So let's practice this. We're going to use chlorine. Write the symbol, the complete symbol for chlorine, when it gains 1 electron. Write the complete chemical symbol for chlorine when it gains 1 electron. What would that look like? So all these questions that I asked during class are the same question I asked on tests and quizzes. So some students will catch on and they'll actually write down the questions that I asked, because that's a good review. It's just I don't give study guides for tests. All right. I'm giving you the question. What?
No, I'm not saying what. I'm just saying like notes are very
So that's why I asked all these questions. So the questions I'm asking are your test questions. Okay, so that's kind of your review. Okay. All right, everybody got it? What's the symbol for chlorine? Okay, atomic number? Sorry, I had it. Mass number? Like, oh, you scared me. I thought maybe change I didn't know. Okay, so this is what we've been working on before. Now we have a change. We have chlorine that has gained an electron. So what's my charge? -1. Okay, so the number of electrons that the atom gains is the charge that it becomes.
okay, so you do that every time.
Yes.
After.
Yes. I know. Practice. Okay, practice. Yeah. We will do what we call polyatomic ions probably another week or two, and then you'll have lots of practice on writing the charges and whatnot with that. Okay? Now, if we go back to our P&Es for practice, how many protons? How many neutrons? and how many electrons. Okay. So same thing we did yesterday. We're just kind of adding or building it on top of that. All right, let's try one more. How about nitrogen when it gains 3 electrons? Write this number for nitrogen when it gains. Oh, do you need to see that?
No, I got it.
Okay. You just kind of got this like.
Yeah, that's just kind of.
That's kind of what she's doing right now.
Well, anytime if I go too fast or I miss you someplace, just say,
I'll ask my friend for help.
your friend for help. You get
Yeah.
Landon?
No. Probably Keisha.
Well, she wasn't here
I missed you
yesterday.
guys, so like I'm not a good source.
Okay, once you have an answer, go ahead and check with somebody next to you. Kind of collaborate. It's dialogue. All right, that's very important for us. You will remember that longer.
Do you like the 14 on top and 7 on the
I should
bottom?
double check it.
Is it 14 on top and then 7 on bottom?
So the bottom number is the atomic number, which is 7. The top number is the mass number, which is 14. So I think you had it switched. Okay, so nitrogen is N. What is the atomic number for nitrogen? Mass number. And then it's gaining 3 electrons, so the charge? 3 minus. Okay, so the number of electrons that it is gaining is the charge. Because it's neutral, it has equal amounts of protons and electrons. So if it's gaining more negative, it becomes that more negative. Okay, so how many protons do we have for practice? How many neutrons? The electrons? Okay. Easy peasy? All right. Okay, now the cool thing with the anions is that there's a name change. Okay, again, this is the new language, is a name change. So when we have a chlorine atom that becomes an ion, or a nitrogen atom becomes an ion, we actually change the name of it. Okay, and what we're going to do is we're going to change the ending to IDE. Okay, so you can jot that down. We have a name change. All we're going to do is change the ending to IDE. And so when you have a quiz or a test, be careful of what you read. That's part of our learning curve here. Okay, so chlorine would be the neutral atom. What would be the name of the ion? Chloride. So you have heard of the name sodium chloride. Okay, sodium fluoride in your toothpaste. Okay, that is referring to the ion in the compound, not the atom. Chlorine atom actually is a gas, a poisonous gas, maybe called mustard gas. You hear about that in history class? Okay, not a good thing to ingest. But sodium chloride, the ion, is okay for your body. You need that electrolyte, especially your athletes who sweat a lot. Right? You need to replenish your system with electrolytes. Okay, nitrogen becomes nitride. Okay, so I need you to understand the name of the element is the neutral atom. The ending changes for an anion. Okay, so when you see chloride, nitride, fluoride, bromide, iodide, sulfide, that tells you, oh, that's an ion. Okay, so you have to be able to pick that up.
How does like one electron change
That's a good question. That's a good question. Maybe I'll use Fe as an example in your diet. Okay, if you eat oatmeal, how many of you guys eat oatmeal? Okay, if you have a Wheaties, Raisin Bran, okay, there's iron inside of your oatmeal, inside your cereal, like actual pieces of metal. Okay? Remember, did you do it in middle school? You take a magnet, a pretty potent magnet, strong magnet, like a cow magnet, and then you take your oatmeal or your Wheaties and you put water in and get it all mushy. And you mush it up and put the magnet inside it and you mush it up a little bit and you pull out the magnet and you'll see these shards of actual pieces of metal. So you're actually eating actual metal, you know. So if you're low in your iron in your diet, suck on a nail or something. Yeah, yeah. Back in my day, I grew up on the farm, a small farm in Ohio, and my mom cooked with cast iron skillets. Does anyone use those today? Okay, a couple of you. Guess what? When you cook with the cast iron skillets, there's the iron metal that goes into your food that you ingest. Isn't that kind of cool? Right? So it's a good diet for you. But it's not cool?
No.
Yeah. Now here's the cool thing though, the cooler thing, is that when this metal breaks down into your body, into your digestive system, it actually breaks down into a 2+ ion. Okay? Your body can't use a 2+ ion. There's something about the structure of this that the body can't break it down. So guess what it does? It goes through a process where it breaks it down to a 3+ ion, and then it can use that into your blood, your erythrocytes, your hemoglobin. Isn't that cool? Okay, so the mystery is we don't know exactly why, but with biochemistry-wise, there's something with the structure of these ions that the body can't handle. What's that? What's that? Benefit of this in your body is with your hemoglobin. So your hemoglobin has these iron little balls to it that attaches to the oxygen in your blood. If you don't have this in your hemoglobin, it's not going to attach to your oxygen. No oxygen, you become anemic. Hemoglobin, it makes the it's kind of the red part of your blood. Okay, so in the red blood cell, the hemoglobin, it's like almost looks like a clover leaf. Kind of this structure, and then embedded inside it, we have this these iron ions. We also have this protein called ferritin. Ferritin is a huge part of distance running. I talk about a ton of this when I'm coaching. Is that in the hemoglobin, heme meaning blood, okay, globin. It's like a glob. It's like a structure. The hemoglobin has this Fe3+, and the oxygen gas comes in and attaches to it. Okay, the darker the red, the more oxygen that you have. Isn't that kind of cool? All right, now oxygen is the fuel for your body to survive, like gas in your car. If no gas in the car, you don't go. It doesn't run. No oxygen in your system, you don't run. You don't. There's no energy. Okay, so oxygen is needed for that. Now, with the oxygen, if you go back to biology, you talked about the photosynthesis for plants, but for us, you talk about the Krebs cycle. You talk about the glyconeogenesis, pyruvic acid cycle. Is that? Okay, so all that is ran by the oxygen. And through that chemical process, your cells produce the ATP in the mitochondria. ATP is the chemical energy that we use to function, that sort of thing. Okay, so if you have low iron in your diet, then that hemoglobin cannot attach the oxygen to it. No oxygen, you become very lethargic, kind of slow, right? Have any of you been anemic before? Distance runners get that way sometimes because we pound. So if our diet does not have the iron content into it, we have runners that become very sluggish. Like, I don't understand, coach. Last week I was running great. All of a sudden, I'm just low energy. I can't move. I'm working hard, but I can't. You know, most likely is that in their diet, the iron content got so low that now there's not enough oxygen to move around the body that we're causing it to. We want it to act at a high level, and it can't because it doesn't have the oxygen content there. Okay. Now, to go a little deeper with this is a good question, by the way. Go deeper with this. It's not necessarily the iron in your diet that you need. It's a protein called ferritin. Okay? So what I tell my athletes, my runners, is that if you go and get your blood tested, don't have them test if you're anemic. Anemic just tells you if you have a certain amount of iron in your hemoglobin. Okay? So that could be fine. Most often it is. The problem is that there's a protein called ferritin. Ferritin is a guy who holds on to the oxygen and releases it when you need it. If your ferritin level is low, it can only release a little bit of oxygen at a time because there's low ferritin, low oxygen. The higher the ferritin, the higher the protein content, it's going to release a lot of oxygen. So when our runners get kind of sluggish and so forth, it's most often because their ferritin level is low. Okay, so if you go to a GNC or pharmacy or whatever, there's a supplement called iron sulfate. Or it might say ferric sulfate. And that compound will help increase the ferritin in your diet, in your body. It can, but the problem is for an athlete, for a distance runner, when we're pounding 6, 7, 8, 10 miles a day, I mean, you're asking it to demand a lot from it. And so because of that, it needs some help. So either your diet has to get that, which is a better way to go, or you should take a supplement. If you talk to any sports nutritionist or any dietitian, they would tell you, fix your diet. Don't do supplements, fix your diet. Okay, make sure you're eating, using the cast iron skills, make sure you're eating the proper food so you don't have to take supplements and whatnot. That's the better way to go. Okay. Isn't that cool? That was all chemistry right there. That was biochem. Yeah, that's the cool stuff. So I use a ton of that in my own training, but also in my coaching, when I'm coaching distance runners and whatnot. We talk about that all the time. So what I tell my runners is that once we start, we have there's different phases in our trainings. The first phase is aerobic, building up your aerobic capacity, capillary beds, your blood flow, your endurance to running and so forth. I tell them once you get past that stage, you might want to start taking the supplements or changing your diet, because I guarantee after about 3 or 4 months of this training, you're going to get kind of fatigued. All right. So yeah, a lot of iron content. So you got your red meat, you got your broccoli, you have your strawberries or have iron in it, your fruits and that sort of thing. It's anything green leafy stuff with that. But a lot of red meat, if you're a red meat person, a lot of, I grew up on the farm, so steak and potatoes. You know, that was what I grew up on. Yeah, you can look at it. There's a ton of stuff out there. The
It's the iron, not the ferritin. Like ferritin comes from eating iron.
Correct. Right. Yep. Okay. That's awesome. We can go in further. We can talk about more about this too. Especially we can talk about when you pound, when you're running your pound and so forth. You're actually breaking blood vessels in your feet, and that breaking of blood vessels is losing blood. You lose blood. You lose the iron content and the oxygen content. So there's a lot of science that goes on to our sport for running and so forth. I could teach a whole class on that. I thought about doing that. I thought about teaching a running class. Cool. We would actually train. We would talk about the science behind running. We talk about the nutrition, and then we would actually we would do some testing, all right? And then at the end, we can, want any kind of cool class to take? Science of running. It'd be cool. It'd be sweet, yeah. It'd be awesome. Okay, so whoever's ever watching this video, that was just a little bit of extension because we're videotaping. It's all good though. It's all good. Okay, so if we go back up to naming the anions, changing the ending to IDE. Okay, so bromine becomes bromide, oxygen becomes oxide, fluorine becomes fluoride. All right, so we have all those. Now, the non-metal elements are the ones that tend to gain electrons. As you go through these notes, I'm giving you a little bits of information, and then we apply it. That's the critical part, the critical thinking part of this class. We're not just looking at information and memorizing it and then tell me later what the information is. We're actually using that information. Okay, so I might ask you on the test, which of the following elements is going to gain electrons? So if you don't know nonmetals, then you're kind of stuck. Okay, so we're not just memorizing factoids here. We wanted to take the information and then use it or apply it in a critical thinking sense. So the question would be, where are the nonmetals, right? Where are the nonmetals? So on your periodic table, you want to get it handy. We're going to mark it up. There's a lot of hidden treasures. You see the movie National Treasures, right? Hidden treasures. 1 and 2, both of them are good. There's a lot of hidden information on the periodic table. When you look at it, it looks kind of bland to you. Right? This morning in our AP class, we went through the periodic table, and we listed about 25 different things on the board that is on the periodic table that you don't see. Pretty cool, okay? All right, so here we go. On the periodic table, on my table, there's a red staircase. There's a red staircase, okay? You need to, if it's not on your periodic table, put a dark line where that staircase is, please. All right, so we have this red staircase, so between boron and aluminum, just zigzag it down. Okay, zigzag it down.
So we can see on the other side to the end.
Yeah, it goes all the way down to the bottom between astatine and polonium.
Why are aluminum, zinc, and silver?
Okay, well, for a side note, not now, but for a side note, aluminum is the only true metal in this family. It's the only metal that acts like a metal in this family. Okay? Zinc and silver are the only two transition metals that don't change their charge. We'll get into this later, but we have this section here in the middle of the periodic table called transition metals. They can have more than one charge. Copper can be a 1 plus or a 2 plus. Nickel can be a 2 plus, 3 plus, or 5 plus. Okay? But zinc and silver are the only exceptions, and so that's why they're green that way. Okay? But later on, yeah. Good question. I like that inquisitiveness. Okay, so everybody have the staircase? All right. Everything to the right of the staircase are nonmetals. There you go. All the elements to the right of the staircase are nonmetals. Okay, carbon's a nonmetal, oxygen gas, fluorine gas, selenium. Selenium, by the way, is in fish. Very important for your blood flow as well. Okay, just FYI, it's in fish and it's good for your blood flow. So it's good for your diet. Eat fish.
Does selenium, you know how you said that's good for your diet since fish, does that have to do with the omega like 3 and all that? You know?
Yes, yes, yeah, very good. So the selenium is associated with the omega 3s and omega. I don't know. There's a new one out that they have now too, Julia. Yeah. So the bottom part down here. Okay. Again, later on, these are called the inner transition metals, and they actually fit up into this section here. So the way that this periodic table is set up, the way you see it, is not the way it really is. Okay. So in your book, when we talk about the periodic table, there's a picture in there that shows it kind of elongated. All right. So these two columns here go up in here, and everything is pushed out a little bit. We take them out and put them at the bottom, so it squishes it together, so it's more easily used. Okay. There are different types of periodic tables. So there's a pyramid periodic table, and there's a spiral periodic table, which is kind of cool. Yeah, I know.
Look this up. I need to.
It's pretty cool. I used to have some when you can actually make a pyramid, like a cutout type of thing. I can see if I can find it. I used to do it for fun a lot of years ago. Anyway, so it depends on what area of chemistry that you're studying. Those periodic tables can come in very handy. It's not included, so they're all metals. Not included because it goes up into the middle to the left of the staircase. It's not. They're not non. They're.
They
They're not.
Are metals.
They're metals. There you go. There you go. They're metals. So we only have a very few nonmetals. Not very many. Of all of the elements on the periodic table, only this section here, all right, are your nonmetals. Okay.
Just from looking at it, and you can like see the heaviest element. Theoretically, are there like other ones out there, heavier elements,
As far as been discovered or man-made?
been discovered? Like, could there be? It's more of like a,
In theory, yes. In theory, yes. There could be other elements beyond here. But these have all been man-made. So 107 through, I think, 118 now, they're all man-made.
be man-made component.
You build it. Protons, neutrons, cyclotrons, you put them together and so forth. Yeah, you know. But here's a problem with that. Why? People spend, and this is my 2 cents, but people spend all this money on research to build these new atoms and new elements or whatever, but they don't last more than a millisecond. They're not stable. So why put all that money into it? So I understand for the sake of science and understanding how things work and so forth, but why not put that money to a use that can be more helpful, I guess? That's kind of my bent on it. Oh well. Anyway, so they just named, I think, 7 of these this past summer. It takes a couple years to go through a process and stuff, and they just named about 7 of the new elements that were man-made. Nothing discovered, they just made them in the laboratory.
Even if they don't last more than like a second, like they blow up or like what is?
Yeah, they release energy and just kind of fizz out, die out and stuff, yeah. Okay, you guys have great questions today. I love it. This is good. Noble gases, though. Where are the noble gases? You learned this way back in the day. Noble gases are the last column. Okay, so these are the noble gases here, AA, this last column. They're all noble gases. And these guys are the only ones that do not lose or gain electrons. Okay, they are considered stable. If you go back to your chemistry background, you talked about complete shells or energy levels. You've kind of heard that phrase before. We'll talk about that next unit. So the noble gases are not going to gain or lose electrons. Okay, they're stable. We'll use that word stable. Again, so that last column. Okay. All right, now, since we're on the periodic table, I want to add to it a little bit. We have these substances called metalloids. Metalloids. They used to be called semi-metals. They changed that a few years ago to metalloids. And the cool thing about metalloids is they have both metallic and non-metallic characteristics. They act like a metal and a non-metal, which is kind of neat. Some of your semiconductors are metalloids. Okay, so metalloids, they have both metallic and non-metallic characteristics. All right, there are 6 of them. There are 6 of them on the periodic table. Okay, you can highlight this, you can write down whatever you want to. We're going to start with boron, right on the staircase. Okay, right along the staircase. Boron, silicon, arsenic, tellurium. That's 4 of them. Okay, so right along the staircase, boron, silicon, arsenic, tellurium. Those are 4 metalloids. The astatine, some books will show it as a metalloid and some books will not. It is considered radioactive. Okay, so that they tend to consider it no. On the left side of the staircase, we have germanium and antimony. Again, notice how they are touching the staircase. Germanium and antimony.
Wait,
So boron, silicon, arsenic, tellurium. So all these elements that are touching the staircase on the right side. On the left side, we have the germanium and antimony that are touching the staircase. Goes back to the question that was asked earlier. Aluminum is not a metalloid because it's a true metal. It acts like a metal. There's no non-metal characteristics of it. Polonium is also considered radioactive, so that's not considered a metalloid. Okay, so on the quizzes and tests coming up here, I'll ask you, like, which of the following is or is not a metalloid? I might ask you a definition of a metalloid. Okay, now, since the metalloids have both metallic and non-metallic characteristics, we also need to go one step further. If a metalloid is on the right side of the staircase, which way do you think it's going to behave most of, metal or non-metal? Non-metal, because it's on the right side of the staircase. Okay, so silicon does have both metallic and non-metallic characteristics, but most of the time it's going to behave like a non-metal. And same for arsenic and tellurium and boron. Germanium and antimony, all right, have metal non-metal characteristics, but they're going to be mostly metal in nature because they're on the left side of the staircase. Okay? All right. Whew. You good with that info? All right. Well, if atoms can gain electrons, they can also lose electrons. Okay? So if an atom loses an electron, it's going to become a positively charged ion. So if we have magnesium as a neutral atom, 12 protons, 12 electrons, and again, if it loses an electron, let's go to 10. If we do a math here, what charge does it become? 2 positive. So if you lose electrons, you become a positive ion. Okay? Now, a positive ion also has a name. What do we call a negative ion? An anion. Okay. A positive ion, I remember it one of two ways. One's kind of corny, but I kind of like it. How many of you have cats at home or been around cats? Okay, all right. What are these things that cats have? Paws, and they're cats. So if we have a positive ion, we have a cation. Does that help you?
Yeah, you do it again.
So if we have a positive ion, right, we call it a cation. So that helps you remember that. Positive, right? Some people, math-wise, will say, hey, the cation has a T and it looks like a plus sign. And that could help you too. Okay? So again, we're using these terms. Anion, cations, metalloids, metals, nonmetals, transition metals. So we have all these terms that we got to keep track of. All right, let's do aluminum here. So let's write the symbol for aluminum that loses 3 electrons. What would that look like? Let's do aluminum that loses 3 electrons. Okay. What's the atomic number for aluminum? Mass number? And it lost 3 electrons, so now it becomes 3 positive. Okay? If it gained 3 electrons, it becomes 3 negative. If it loses 3 electrons, it becomes 3 positive. Okay? All right, so just for practice, P and E's. Now your protons, neutrons, electrons. Got it? Okay. Now, the cool thing with this, no name change. Anions change name. The cations do not. So we simply say sodium ion, or we say magnesium ion. Right? We don't say magnesiumide or sodiumide. Okay? Metals are going to lose electrons. Where are the metals located? On the left side. On the left side of the periodic table. So about 90% of the elements are metallic. They're going to give up electrons. Okay?
Wait, did we not need that last question?
I just answered it. Where, it just said, where are the metals? To the left of the staircase. Okay, the worksheet that you have, you want to do odds or evens?
Even.
Wait, no, wait.
Whoa, let's think here.
I want to do evens because there's the last one's an odd.
There's
There
one
we go.
less.
Yeah, we do
You want to do less work?
Yeah. Wait, what are we doing?
The worksheet, odds or evens. I'm just asking just
For homework?
for homework, yeah.
For sure. You always want to do evens.
You could do both.
No.
You can do them all if you want.
All of the first
Can I
10.
get some points back on my the fun sheet if I do them both?
No,
Because
we can
Miss
drop that
Miss
down.
Heather decided to drop my grade here.
By the time we get done, it would be a wash. Seriously. Okay, you're going to do the evens.